Welcome to the deep dive. You've probably seen the headlines. Things seem to be escalating a bit between India and Pakistan.
Yeah, there were reports mentioning littering ammunitions, which sounds pretty serious.
It does, and it really throws a spotlight onto their air defense capabilities. So today we want to, take a closer look at two key systems.
Right. We're talking about India's S-400, the Russian one, and Pakistan's HQ-9, which they got from China.
Exactly. And there have been these reports, haven't there, about something called Operation Sinandor.
That's right. The reports allege Pakistan used swarm drone tactics, targeting quite a few significant Indian locations.
Places like Antipora, Srinagar, Jammu, even Amritsar and Ludhiana.
And Bogue, yeah. Military sites, strategic cities. It sounds like a coordinated effort based on those reports.
And India's reported response was pretty telling, apparently activating the S-400 system.
And also deploying their indigenous Akash missiles.
So the big question for us really is, how do these systems, the S-400 and the HQ-9, stack up? What can they actually do?
And what does deploying them like this signify in the current climate?
Yeah. Our mission today is to kind of cut through the technical details and just get a handle on what these systems are about and why they matter right now.
Let's do it.
Okay, let's start with India's S-400. What's its main job? What kind of threats is it really built for?
So the S-400, coming from Russia, its primary role is dealing with the big stuff. Think high-speed jets, high-altitude bombers, even ballistic missiles.
The really serious, fast-moving threats.
Exactly. It's sort of the top tier in what you'd call a layered defense strategy.
Layered defense. Okay, so it's not meant to operate completely alone.
No, not ideally. It's designed to work alongside other systems. And in this specific context, India's Akash missile system is highly relevant.
Ah, the Akash. You mentioned that was deployed too, so how does that fit in?
Well, the Akash is designed for the other end of the spectrum, more or less.
Hmm.
It targets lower flying, generally slower threats.
Like helicopters.
Helicopters, yeah, and crucially in this context, drones, especially drone swarms.
Right, so Akash is the specialist for those lower, slower targets that maybe the S-400 isn't optimized for.
You could put it that way. It fills a different niche in the overall defense picture.
Tell us a bit more about the Akash then. What are its specs?
Okay, so the Akash is supersonic. It travels pretty fast, up to Mach 2.5.
2.5 times the speed of sound. Wow.
Yeah, which gives it a good closing speed on, things like drones. Its range is around 25 to 30 kilometers.
Okay. Decent reach for those kinds of targets.
Enough to engage them before they pose an immediate threat to a specific site, ideally.
Got it. So S-400 for the high-end threats, Akash complementing it for the lower, maybe slower ones. Let's circle back to the S-400 itself. Russian-made, we know that. What are the key parts? What makes it tick?
Okay, an S-400 battery or system has several main components. First, obviously, the missile launchers.
Right.
These are usually on these big, rugged Baz tractor trucks. Very mobile. Each truck can carry up to 4 launch tubes holding the missiles.
Mobility seems key here.
Definitely. Then you get the mobile command and control post. That's like the nerve center. It manages the whole engagement process.
The brain of the operation.
Pretty much.
Yeah.
And then critically, the radars. There are several. The main one is the long-range surveillance radar.
The one with the cool names.
Ha! Yeah, the 91N6E, sometimes called Big Bird or Tombstone. This thing had a massive detection range, reportedly up to 600 kilometers.
600 kilometers. That's huge. What can it see out there?
All sorts of things. Aircraft, helicopters, cruise missiles, ballistic missiles, and yes, drones too. It can apparently track up to 300 targets simultaneously.
300 targets at once. That's incredible processing power.
It really is. It gives you that wide situational awareness. Then you have the engagement radar, sometimes called Gravestone.
And that one does what?
Its job is to guide the missiles. It has a shorter range, around 400 kilometers, but it locks on to specific targets the command post designates and provides guidance data. It's designed to track targets at various altitudes.
Okay, so Big Bird sees everything, Gravestone guides the missiles. Any other radars?
There's usually an all-altitude acquisition radar, sometimes referred to as the 40V6 unit. This one's specifically good at picking up low-flying targets.
The ones trying to sneak under the main radar coverage?
Exactly, using terrain masking. This radar helps counter that. And there's mention of a mobile mast system, potentially linked to the 40V6.
What does the mast do? Just lifts the radar higher?
Essentially, yes. Elevating the radar improves its line of sight over terrain obstacles, making it better at spotting those low flyers further out.
Makes sense. Get a better vantage point. Now, you mentioned launch tubes. Does the S-400 fire just one type of missile?
No, that's one of its key strengths, flexibility. It uses a family of different missiles.
Different ranges.
Exactly. There are shorter range ones, maybe around 40 kilometers, medium range, up to maybe 120 kilometers. Long-range missiles reaching about 250 kilometers.
And the headline figure.
And then the very long-range missile, the one that gets the most attention, which can reportedly hit targets up to 400 kilometers away.
So it can tailor the response based on the threat distance.
Precisely. You don't waste a 400-kilometer missile on a target 50 kilometers away.
Right. Okay, so let's put it all together. A potential threat appears. What's the sequence? How does it work in practice?
Okay, so first step, detection. That's usually the job of the Big Bird long-range radar. It picks up incoming objects, potentially hundreds of them.
Tracking up to 300, you said?
Right. That track data flows immediately to the command and control post.
Where they figure out what's what.
Yep. Identification friend or foe, IFF systems kick in. They assess the trajectory, speed, behavior. Is it hostile? Is it civilian?
And if it's deemed hostile?
Then the engagement decision is made, authorization is given. The command post then assigns targets to specific launchers.
Choosing the right missile type for the range.
Correct. And typically, standard operating procedure is to launch 2 missiles per target.
2? Why 2?
Redundancy increases the probability of a kill, P, as they call it. If the first missile misses or is decoyed, the second one has a chance.
A sort of insurance policy.
Kind of, yeah. As the missiles are in flight, the engagement radar, the Gravestone, is providing guidance updates.
Keeping them on track.
Exactly. Using the continuous track data also coming from the surveillance radars.
Yeah.
And if it's a low-flying target...
And the mast system comes into play.
Right. The all-altitude radar, possibly elevated on the mast, helps detect it, allowing engagement, probably with the medium-range interceptors. It's a very integrated and coordinated process.
It sounds incredibly complex. So what's the total engagement capacity? We know it tracks 300, but how many can it shoot at simultaneously?
The numbers you often see are that a single S-400 system or battalion can engage somewhere between 60 and 80 targets at the same time.
60 to 80?
Yeah, while guiding up to 160 missiles simultaneously that fits with the 2 missiles per target idea.
That's a massive capability, especially if you're facing a complex attack.
It is. It suggests an ability to handle saturation attacks to some extent.
But as always, there must be limitations, right? No system's perfect.
Absolutely. A major one is physics, the curvature of the Earth.
Ah, the horizon problem.
Exactly. Radar travels in straight lines, so very low-flying targets can hide below the radar horizon until they get relatively close.
How close are we talking?
Detection might only happen at, say, 40 kilometers or even less for something really hugging the terrain, like a cruise missile. That reduces reaction time significantly.
So potential blind spots, slowdown, anything else?
Well, its effectiveness always depends on integration with other systems, the skill of the crews, the specific tactics used by an attacker, electronic warfare, lots of factors. And of course, maintenance and readiness are crucial.
Right. It's never just about the hardware specs on paper. Okay, let's pivot to Pakistan's main system, the HQ-9. You mentioned it's Chinese, but with Russian roots.
Yes, that's the understanding. The HQ-9 is a Chinese development, but it's widely reported to be based on or heavily influenced by the older Russian S-300 system.
So S-300, not S-400. That seems like an important distinction.
It is. The S-400 is a significantly more advanced evolution of the S-300 family. So the HQ-9 is derived from an earlier generation, technologically speaking.
Okay, so how does it compare broadly to the S-400 in terms of performance?
The main differences are in range and capacity. The S-400 surveillance radar range, as we said, is up to 600 kilometers. The HQ-9's comparable radar is generally sighted around 250 kilometers.
Okay, less than half the detection range.
Pretty much. And the engagement range difference is also significant. S-400 maxes out at that reported 400 kilometers.
While the HQ-9...
The HQ-9's maximum engagement range is typically stated as around 120 kilometers, maybe a bit more with later variants, but nowhere near the S-400's reach.
So a big difference in how far out they can see threats and how far out they can engage them.
A very significant difference, yes. It means, theoretically, the S-400 provides a much larger defensive bubble and more reaction time.
Does the HQ-9 work on similar principles otherwise?
Yeah.
Radar, command post, launchers?
Generally, yes. Systems derived from the S-300 family share that basic architecture. Surveillance radar feeds data to a command post, which directs launchers equipped with guidance radars. The specifics differ, but the concept is similar.
Okay, so let's zoom out again. We have these advanced systems, S-400 and HQ-9, reportedly being deployed, potentially in response to drone and missile activity. What does this deployment signal?
Well, deploying systems like these isn't trivial. It signals that the perceived threat level is high.
Even if the threat is drones. You mentioned the S-400 was reportedly activated in response to those alleged drone swarms. But isn't Akash meant for drones?
That's an interesting point. It could suggest a few things. Maybe the scale of the reported drone attack was concerning, or perhaps there were worries about the drone's capabilities, or maybe it was just activating the entire integrated air defense network as a precaution. Using the S-400 against drones might seem like overkill, but it depends on the context.
And this layered approach India seems to be using S-400 Akash. What does that strategy tell us?
It really highlights the need for versatility. Modern air threats are diverse. You've got high-fast jets, ballistic missiles, stealthy cruise missiles, and now, increasingly, swarms of cheaper, smaller drones.
One size doesn't fit all.
Exactly. Relying only on a high-end system like the S-400 could leave you vulnerable to saturation by lower-end threats like drone swarms. Having systems like Akash specifically designed to counter those threats efficiently makes strategic sense.
So it's about having the right tool for each specific job.
Precisely. And it forces a potential adversary to consider a wider range of countermeasures.
What about from Pakistan's perspective? Given the HQ-9's shorter range compared to the S-400, how might they be thinking about their overall air defense? Are there other systems complementing the HQ-9?
That's a good question. While we're focusing on HQ-9 versus S-400, Pakistan certainly has other air defense assets, shorter range systems, fighter aircraft integration. They'd likely rely on a combination of systems and potentially different tactics to try and mitigate the S-400's range advantage, perhaps focusing on point defense or trying to use terrain differently.
So the chess game continues, trying to counter the opponent's strengths.
Always. And again, just to be clear, we're looking at the reported capabilities and deployments here. We're not endorsing any side's claims about the conflict or how effective their systems actually are in combat. That's a whole different, much harder question to answer.
Absolutely understood. Our focus is purely on understanding the tech and the reported situation. So just to summarize the core differences one last time.
Sure. India's S-400, Russian-made, top-tier system, very long-range, 600-kilometer detection, 400-kilometer engagement, built for high-end threats, but part of a layered defense with systems like Akash for lower-end ones. High capacity for tracking and engaging multiple targets.
Okay. And the HQ-9?
Pakistan's HQ-9. Chinese-made, based on the older Russian S-300. Shorter ranges, roughly 250-kilometer detection,
Yeah.
120-kilometer engagement. Shares a similar basic operating principle, but is generally considered less capable than the S-400, particularly in range and likely processing power.
Got it. And seeing these deployed, especially in response to reported drone and missile activity, really underlines their strategic value in this tense environment.
Definitely. It shows how critical robust air defense is perceived to be against this evolving mix of aerial threats.
Which brings us, I think, to the aha moment, or the key takeaway. It's understanding that strategic logic behind layering defenses, using different systems for different threats, and recognizing the challenge posed by new tactics, like those reported drone swarms, which demand specific answers.
It's a constant back and forth. Offensive capabilities evolve, defensive capabilities adapt, and vice versa. It's a cycle.
Which leads perfectly to our final thought for you, the listener. Considering this ongoing evolution, this arms race in the sky, really,
Wow.
what do you think comes next?
Yeah, what might be the next major shift? Think about advancements in stealth, hypersonic missiles, AI and drone swarms, counter-drone tech, electronic warfare. What's the next paradigm shift likely to be in air warfare and strategic deterrence, particularly in this region?
Definitely something to think about.